Here we are going to evaluate. Recall that those vertical bars represent absolute value, which is the distance from 0. So here I have that negative 1/4 is 1/4 from 0. And then this negative on the outside says to do the opposite of that. So we get back to negative 1/4. The negative on the inside, you're just thinking about how far is that number from 0. But if there's a negative on the outside, you take the opposite of the absolute value. This is a digital lesson, so feel free to follow along on your computer or with the video. So who was off by more? Well, Lily was off by 1, 2, 3, 4, 5, 6, 7, 8. And Ethan was off by 22. So Ethan was off by more jelly beans. But does that necessarily mean that she is a better estimator? If we think about it as a percentage, who did a better job estimating? We're going to look at percent error in the rest of this lesson. Let's find out how good of an estimator you are. Okay, round 1. How far do you think it is from Sacramento, California to Baton Rouge, Louisiana in miles? I'm going to guess around 1,700 miles. So you can see that was an underestimation. What do you notice and what do you wonder? I noticed that I was off or incorrect. My error was 107 miles. And since I was under, I was below by 107. The actual distance is 1,807. I wonder if my peers' estimations showed up. how I would rank in comparison to their approximations or estimations. Before round 2, you have 5 more chances to practice estimating differences. How far do you think it is from Salem, Oregon to Phoenix, Arizona? Well, from here to Louisiana, it was 1,807, and this is shorter, so it might be around 750. And again, I underestimated. Let's look at a new location. This one is longer than that line from Salem to Phoenix, but not quite as long as it was from Sacramento to Baton Rouge. I'm going to guess 1,100. And I was too short again. This time I'm going to guess 1,250. Ooh, I was very close that time. This is a short one. I'm going to guess around 675. I was close, but I was still under. And the last location. This one appears to be even shorter, probably around 600. Oop, 746. It was actually longer. I think because this dot or this pin was on part of the line. Maybe I misinterpreted that. Here are your 5 estimates. For each one, find the difference between your estimate and the actual distance. Then find the absolute value of the difference, which is the absolute error. So we're going to take the actual and subtract it from our estimate. So 750 minus 985. And that is negative 235. But the absolute error is just 235. 1,100 minus 1,349 is negative 249 with an absolute value of 249. 1,250 minus 1,258 is negative 8, and that has an absolute value of 8. 675 minus 704 is negative 29 with an absolute value of 29. And 600 minus 746 is negative 146 with an absolute value of 146. If you ever overestimated, your differences should come out positive, and your absolute error is also going to be a positive because it's a distance which is measured with positive numbers. Round 2, how far do you think it is from Baton Rouge, Louisiana to Austin, Texas in miles? This seems like the shortest one so far. I'm going to guess around 430 miles. Oh, that was an overestimate. What do you notice? What do you wonder? This time, since I overestimated, it doesn't show the error, but it shows the absolute error is 39. If you are participating in class, you should also see your peers listed on this leaderboard, so there will be multiple rows. How my approximation would compare those of my peers or of my classmates. Looking at only at absolute error doesn't seem like a fair way to compare estimates. What might be another way to compare our estimates? We may look at a percentage of how much error there is compared to the actual distances. Earlier, you estimated that the distance from Baton Rouge to Sacramento is 1,700 miles. The actual distance was 1,807 miles, and you found an absolute error of your estimate to be 107. Determine your percent error. So in a percent error problem, we put our error divided by the actual. So the actual distance is 1,807. We can cross multiply and then divide. 107 times 100 divided by 1,807 comes out to about 5.92142. We're going to round our percent to 2 decimal spots here. So the 1 makes the 2 stay, so I have about 5.92%. Here are your 5 estimates from earlier. Find the percent error for each and round to the nearest percent. Did it tell me what to round to here? No. So on this one, we're going to round to the nearest whole number. All right, so I have an absolute error of 235. The actual distance was 985. Cross multiply, then divide by 985. And that is 23.8, but the 8 rounds it up, so we are going to write 24%. For the next one, the error is 249, and the actual was 1,349. Cross multiply, then divide. And that is about 18%. The error divided by the actual. Cross multiply, 8 times 100, then divide by 1,258. Is about 0.6, so then that rounds to 1%. That was my best one so far. Now we need 29 divided by the actual. Cross multiply, then divide by 704. 29 times 100 divided by 704 is approximately 4%. And then 146, our error, divided by the actual. Cross multiply 146 times 100, then divide by 746 is about 20% if we round. So here's the absolute error and then the percent error. And then for round 2, our error and our percent error. Which leaderboard do you think is a fair way to determine whose estimates are better? So using absolute error or percent error. This would be a better representation if I had more students' answers presented. But just based on how many miles or how much percent. The percent error is going to give us a representation in comparison to how large that distance really is. So percent error is better because it's easier to compare how accurate the predictions are based on how big the measurements are. So if you're off by 5 in a small number, it's not as good as if you're off by 5 when you have a huge quantity. So the percent error gives us a comparison of how big or how massive that piece really is. So let's say, for example, you were 5 off in a situation of 10. Well, you're pretty far from the actual answer. But if you were only 5 away and the actual quantity was in the thousands, that's not as big of a deal. Yuyan estimates the distance from Austin, Texas to Des Moines, Iowa is 750 miles. The actual distance is 815. She does the following to determine the percent error. She subtracts and she gets negative 65. Then she finds the absolute error by taking the absolute value of negative 65. Then she takes the error and divides by her guess, and she turns it into a percent. Do you agree with Yuyan? If not, what mistake did she make? I disagree with Yuyan. The mistake she made is that she divided her error by her estimation. She should have divided the error by the actual distance to Des Moines. She should have divided by 815 instead of 750 here. There is a bike race from Los Angeles, California to New York. New York. The range of estimates made by racers for the length of the race is from 2,445 to 3,000. The actual distance in the range of the racer's estimate is in the range of the racer's estimates. Can you determine the percent error in this case? Why? The least possible error would be if somebody got the answer right on the actual distance, and so that would be 0 miles off. What is the least possible percent error? Well, if they're 0 miles off, then that's 0% error. If they guess the correct distance, or predict or estimate the correct distance, then there would be no error. They would be correct. What is the greatest possible absolute error? Well, the difference between 2,445 and 3,000 is 555 miles. So the most miles away that their guess could be from the actual distance is 555. Now our possible extremes, meaning like the lowest amount versus the highest amount, could be 3,000 or 2,445. We're looking for the greatest error here. So 555 times 100 divided by 3,000 is 18.5%. But 555 times 100 divided by 2,445 comes out to approximately 23% if we round. So the greatest possible error is that 23%. It's greater than 18.5 or 0 if somebody guessed it exactly. Except I put that in the wrong box. 555, 23%. And then explain. The lowest possible distance is 2,445, and the highest or the greatest possible distance is 3,000. When we calculated the error, the percent error, in both cases, the greatest percent error was about 23%. What is the range of possible percent errors for this situation? We talked about how it could be from 18.5, it could be 0, or it could be up to 23. So the range is from 0% error if they guessed the distance correctly to about 23%. It didn't come out to exactly 23, it was about 22.69 or so, but we rounded up to 23%. Now let's revisit Lily and Ethan. Now that you know about percent error, who do you think had a better estimate? I think Ethan had a better estimate because he had more jelly beans and he wasn't too far away. He had a 22 out of 701 is better than, she was off by, what did we say, 8 out of 77? And let's just verify that real quick. 22 out of 701 or 8 out of 77. We're going to cross multiply and divide. So 22 times 100 divided by 701 is approximately 3.1%. 8 times 100 divided by 77 is about 10.4%. And that is the end of lesson 19. Make sure you have any notes or work demonstrated in your workbook, and the rest can be completed online through the digital platform.